I think we're probably good to go. So let's get in and good morning, good afternoon, good evening, everyone. Oh, here's more people. Welcome to our webinar about Ingress protection. We're thrilled to have you with us today. And our presenters that you'll hear from this in just a minute are Mark Chadwick, who's our segment director for market management e-mobility, and our global technologist, John O'Brien. And for a little bit of housekeeping before we kick off, the presentation portion of the webinar will last for approximately 30 minutes, and then we'll follow that with a Q&A session. So feel free to type any questions that you have that come up into the chat box as they come up, and then we will answer them in the Q&A. And just so everybody's aware that the session's recorded, and we're going to share the presentation with you afterwards. So thanks again for joining, and I think we'll jump straight in and hand over to Mark.
Thank you, Miriam. And yeah, just to reiterate, thank you everybody for your time today and your participation. I'm going to kick off before I hand over to John, who's going to go through some of the technical detail here about ingress protection. But I just wanted to start with, touch on why is it important for ingress protection. We all know about it, we've all heard it, but there's a number of reasons here, and it's becoming more important. And I think firstly, we talk about, obviously, products in harsh environments. It's key that we protect the internal components. And that could be in multiple industries and multiple ingress ratings, and we'll touch on what them ratings are. But it's clear that when we put products in harsh environments, to make sure they perform efficiently and with longevity, and to reduce the warranty potential claims and downtime of critical systems, we have to protect them internal components. And that's not just from dust. It could be from moisture or water and other contaminants. I think on top of that, obviously, as a supplier, we want to make sure we've got a sustainable business. If we're supplying product that's going to the end market and the end users having issues, it's not performing as it should, that reflects badly on the supply chain. So for us, building that ingress protection assembly with fasteners in it is critical. And again, we can talk about automotive or consumer electronics and the different ranges, but our consumers, our customers have choices. We want to make sure the products that we design, that we supply, work as they should in the harsh environments that they're meant to. So I just wanted to touch on that. I'm going to hand over to John O'Brien, who's going to go through now just how we rate ingress protection. And again, there's ways to rate it. What does it mean? How can we achieve that with current solutions? What's PEM's offering to the market? And important for our customers, how can we confirm and how can we ensure that products we supply meet and are tested to certain specifications? So, John, I will hand over to you to go through the next section of the webinar, please.
Thank you, Mark. And hello, everybody. And you're welcome to our webinar. Ingress protection ratings, how it's defined and controlled. Of course, this is an engineering standard, and ingress protection, or IP, as we refer to it as, is a measure of how good we are at preventing something from getting within an enclosure. So the way this is defined in the standard is written here on the right hand side. This graphic here is taken directly from the standard, which, if any of you are interested in, is from ISO 20653, or exactly the same as the IEC 60529. So with regard to ingress, it's not just water. And, I suppose when people think about IP ratings, that's what they think about first of all, is how do you keep water out? Because that's probably most of what we see, but it's not just that. And the way the IP standard is done, you've got IP followed by 2 digits. The first digit signifies protection against a solid object or dust, small particles. So if you think about something like in your home, an electrical socket, that's got an IP rating. Obviously, the IP rating doesn't apply to liquid unless it's an outdoor socket. But if it's an indoor socket, it refers to sticking your finger into that, or in most cases, actually, what they're trying to prevent happening is a child putting their finger in there and getting an electrical shock. And that's how you apply the first letter of the rating. And those rate from 1 to 6. And as you go along, the particle size gets smaller and smaller. So as you can see, if you want a socket, it should be IP6 at a minimum, IP6 something. Now, if we look at the second digit, this more commonly refers to liquid, and it signifies your protection. And it's not just water. It also, even though it's water we use in the test to this standard, it's not just water. It also applies to other liquids as well. So typical rating is IP66, where the second 6 refers to water, and that's protection against high pressure jets of water. That also will cover you against rain. So if you've got something like outside lighting in your garden, or a socket, an outside electrical socket, they normally are IP66 rated. The next version up you see is IP67. And the difference between IP66 and 67 is that 67 allows for temporary submersion in water. So that is submersion in water to 1 meter depth for 30 minutes. So essentially, most people would think of that in colloquial terms as being waterproof. So a typical scenario here is modern day smartphones. If you think back to the old days when we had the old phones, certainly if you dropped one of those in the swimming pool or the toilet, it wasn't going to work anymore because they weren't rated to IP67. Nowadays, if you do have an IP67 rated phone, you'd probably be okay dropping it in the pool. However, if you've already left it out in the sun and it overheated, or if you dropped it on concrete previously, you may have disturbed that sealing, so it may not still meet IP67, but you won't know until you fish it out and take a look. But to be quite honest, most of them are very, very good these days and will survive the IP67. A relatively new addition to the standard is IPX9K. And IPX9K is protection against high pressure, high temperature water. And this arose with the advent of hot washes. So if you go to the car wash and they use the high pressure hot wash, what they found was that IP67 wasn't sufficient to keep out the water at high temperature, because what the high temperature was doing was expanding the seals and allowing the water in. So you need greater ingress protection at IPX9K than you do at IP67. So that's the technical basis behind how we define the standard. And in the next couple of slides, I'm going to go through how we test to this particular standard and other ways. So if we move on to the next slide, Mark, we're going to take a look at how do we achieve this when it comes to a fastener and a fastener solution. So typically what we've done in the past is, if you see on the most left-hand side here with loose hardware, is one of the choices was to apply a sealant. So essentially what they used to do was apply a sealant under the head and then push it through the hole and clamp it up. One of the problems with this is that sealant, for the most part, is very messy. So as well as hopefully getting under the head, the sealant also got every place else as well. And in some cases, you were talking about a 2-part sealant, where you had an activator in the sealant also. And that made it even more difficult because there was a very limited time for putting it in place before it cured. And of course, this brings you to the fact that you need the sealant to cure before it gives you a good seal. And also, by the way, if you miss a part of the operation, i.e., you don't get the full 360 under the head of the fastener, well, then that's obviously a leak path, and you will get a leak in that area. So control of the sealant and putting it in the right place was very, very important. Putting the fastener in place as soon as possible, and clamping it up was also important before it actually cured, because once it cured, that was it. Hopefully the seal was in place. The problem that arose after that then, of course, is that a sealant, being normally a polymer based, are prone to UV and chemical degradation. So if your sealant would fail over time. In addition to that, a lot of the polymers used are quite prone to chemicals. So it's fine if you're just using water, but of course, in many cases, it's not just water. We also use coolant or antifreeze, ethylene glycol, also different types of fuels, oils, solvents, soaps, etc. And all of these can attack polymers and obviously break down the sealant. So most applications are good on day one. You want to be sure that this is going to be good on day 10,000. And to get to that, you need confidence in your ingress protection. Of course, the O-ring is a bit of an improvement on the sealing as regards it's not as messy, and you can pre-apply it. It's better in that case. It doesn't give quite as good a seal unless you get that compression load on it to deform the O-ring, create the seal. Without the deformation, i.e. if you lose the clamp load, then you lose the seal. And again, you've got a leak path. Also, when it comes to UV and chemical degradation, the O-ring suffers from the same problems because it too is made from similar or the same polymer. So both of these have a problem. Of course, the other problem with the O-ring is that you may misalign it or pinch it. And in that case, even though you've done everything else right, you still have a leak path. Also, you don't know if it's good or not. So unless you test every single joint, you don't know if the sealant or the O-ring joints are actually good, unless you test a huge amount of them. And even at that, you're not really convinced because there's nothing in the actual process of applying them to tell you that it's good. So therefore, some people go with welding. Don't punch a hole in the panel at all. Just weld the component to it. So we'd be quite familiar with this and how it's done. Single piece component creates a sealed joint. The problem is, though, is you've much more technical equipment required. Emissions during welding, difficult to weld dissimilar materials. The performance of the weld is probably your biggest problem, because looking at the weld, you can go, oh yeah, there's no leak path, which is good, provided it's not me welding. I might burn a hole in the panel, but the leak path will not be there, hopefully, but your mechanical performance may not be there either. And this is usually the problem with welding, is that you've got a very wide distribution of mechanical performance when it comes to welded fasteners. So you've got to err on the side of caution. So therefore, you probably need to spec an even bigger fastener than you actually require, with greater welding and with greater install time to ensure that the weld is good. In addition to that, you err on the side of caution because you want to overweld to ensure that you do get that mechanical joint. So you say, what is the optimum solution? Well, luckily enough, the optimum solution, we have it here today, the PEM IFH stud. So this is an ingress protection flush head stud that's very easy to install. You simply punch a hole in the panel and you install the stud, same as you would any other PEM part. We have a unique design under our head of a new feature that we've added that will allow this to create an ingress protected seal with the metal. So it's metal on metal seal. There is no chemistry involved, so that you don't have any UV or chemical degradation risk. There's no polymers to fade away. There's nothing to pinch. And when you do an installation using controlled by a Hager process, you can monitor that and you can ensure due to the force distance feedback, you know you've got a good seal every single time. No bad emissions, no VOCs, no additional extraction needed for the air in it. And it's a single component solution with no warranty risk, and it can be used in multi-materials. So you don't need to worry about if you change your panel from aluminium to steel to copper or whatever, this will work every time. So we're going to move on to the next slide, and I'll show you some more details on this, on how it works. So Mark, if you want to play the video while I'm talking about this here. We meet the ingress protection levels and exceed them actually, and I'll show you that in a moment, how we can prove that we exceed them for IPX7 and IPX9K. And as I say, simple, punch a hole in the panel and then you press in the fastener and it meets both IPX7, actually exceeds IPX7 and exceeds IPX9K, and available in many materials, including mild steel, stainless steel, copper, aluminum, all of the above. And it's available with Hager auto feed systems, so that you can achieve that high speed, low cost, with reduced WIP and reduced environmental and reduced warranty issues. So we can, what I will do is move on to the next slide and we talk about how we test for IP ratings. And this is the standardized how we test. So as I was saying earlier, the standard is written with water in mind. So IP67, 68. IP67 is submersion for 1 meter for 30 minutes. IP68 is where you go either deeper or for a longer period of time. And this is the test rig here on the right-hand side that we have in our lab. And in this, what we do is we install fasteners, we seal them in the rig, and we add water and we invert them so that the water is at the back of the fastener. On the front, we spray a water detection spray that goes green in the presence of water. And then using compressed air, we can simulate any depth up to, I think, about 100 meters. And this means that we can test our product to whatever the customer requirement is, exactly to the ISO 20653 standard. And what we have found is that all of our parts have passed on this test. Likewise, we built a test rig for the IPX9K. As you can see, the IPX9K standard defines your test rig as having jets at 90 degrees, 60 degrees, 30 degrees, and 0 degrees impinging upon the installed fastener. And that fastener rotates on a turntable, and you apply water at 80 degrees C at 80 to 100 bar pressure with the 12 to 14 liter per minute flow rate. And you test each jet at 30 seconds each. And all our parts have passed this also. One of the downsides of this is that, sorry, Mark, just stick with this for a moment. One of the downsides of this is pass-fail testing. So it either leaks or it doesn't leak. There is nothing to tell us that this has almost passed or almost failed. So from an engineering perspective, it's very hard to tell, is our design almost bad or almost good? So what we've done is we have taken the new advances in industry, and Mark, if you move to the next slide. So the new advances in industry when it comes to leak detection is to use helium vacuum leak detection. And the way this works is that you take a helium-rich environment here and you suck it through the joint. Now, as you know, helium is a very, very small molecule. It's the second smallest molecule available. Hydrogen obviously is smaller, but to be quite honest, hydrogen leak testing is only for the very adventurous. Helium is much, much safer, and that's why we've gone with that. But the way we work this is that typically helium will always leak through the joint. In fact, if any of you have ever bought party balloons, you will see that even those metallized balloons, they're good for a day or two, but the helium eventually leaks through the metal. And it will do so in any metal container. The helium will eventually leak out through a leak path. So using our vacuum leak testing piece of equipment, as you can see in the graphic running below, we have a helium-rich environment. We pull it through the joint and we measure the amount of helium that leaks through that joint. Doing this in conjunction with thousands of parts that we have tested in the water, we are able to correlate our helium leak rates to the IPX7, X8, X9K leak rates also. So in this manner, we're able to set a standard, and we've done this with this piece of equipment across 3 continents, so that we're able to say that we know exactly what that is. And as you can see, I've listed it on the left-hand side there. It's 1 × 10⁻³ millibar per liter per second leak rate is equivalent to IPX7. So that's in a greater than 98% rich helium environment applied at the top of the fastener. And IPX9K, as you can see, is 1 × 10⁻⁴. Now that's a decade lower leak rate is required for IPX9K as opposed to IPX7, which goes a long way to explain why products rated to IP67 failed under the hot jet wash. In fact, the hot jet wash does require a higher leak rate standard, a better performance than under IP67. So if we look at the next slide, I'll show you where those lines are drawn. So you can see IP67, IP69K, and then on the bottom, you can show our performance. And we've done thousands of tests with our parts, and this is what we have seen. So this is the IFH stud Ingress performance. And you can see that we are at least 2 decades, and in some cases 4 decades better than IP69K, which when you take that over a period of time also with aging, we can give a very, very confident answer that yes, IP67 and IP69K, we meet and, as you can see, well exceed those standards and will do so for a long time to come. If you have any questions about the slides that have gone before, please put them into the chat now and I'll address them at the end of the webinar. The next slide I'd like to move on to is what's coming next, because as I say, we've released the IFH, which is the flush head stud, and that's available right now from your PEM representatives and on the PEM site. What we've got coming soon, and this is in response to customer requests also, is a B-nut. So you want the female thread also with the same IPX7 and IPX9K ingress protection standard. And from initial testing, we are very, very confident we're going to deliver this. Again, no sealants, no O-rings, no polymers, no magic, apart from the PEM magic of metal on metal sealing. So this means that the seal you get on day 1 is the seal you get on day 1001, without any rubber gaskets or sealing that can fade away or somehow get pinched or misapplied. Again, full system solution, including automatic Hager installation solution. We also can do in-die solution, both on the FH and on the B-nut. And this will also be available in all the common thread sizes. So that's something to look out for. And that'll probably be we in NPD could be finished with this by the end of this calendar year. So we'd see a launch either by the end of this year or early next year. So Mark, if you want to move on to maybe cover the summary slide.
Yeah, thank you. Well, thank you, John, for that information. I suppose just one thing to add on the last slide. if anybody's got, like John said, if anybody's got a current application, this is going to be released as a standard product. We're able to support applications now if you've got a solution or an opportunity where you need a blind nut. It's something that we can start working with you on straight away. So while we're releasing the standard product, feel free to contact John, myself, or your local distributor or direct PEM partner to discuss your specific application. So before we sort of move on to the Q&A, I suppose I just wanted to summarize this slide and what John's talked about. And really, the IFH stud, like John said, is available, but the IPB, which will be the nut, which is coming very soon, obviously offers the same advantages. First and foremost, we're aware that obviously lower in-place cost for our customers, for you, is critical. And that means using the PEM clinch with the Hager installation solution. That also gives you the confidence that every installation is monitored, is achieved to be a successful installation. With the aim of, obviously the aim here is to reduce warranty issues and downtime in the field. We don't want the products we're putting our fasteners into that you are supplying to your end customers, the users, to fail, because that means warranty claims, but it also means that the system inside potentially is becoming damaged. And that's going to stop critical systems. It could be energy storage, it could be in datacom, multiple injuries, it could be the light and somebody's gone, but it will stop working eventually if it becomes damaged. I think the other thing to think of here is that by removing the need to add solvent, sealants or O-rings, you can reduce your WIP and your lead time of the assemblies. You're not having to have a secondary operation where you're applying an O-ring or you're applying a sealant, which may be an external process. We're also very aware of, obviously, the environment and the concerns of the other methods. So welding, for example, we know the energy usage of welding far exceeds clinching products, and also harmful emissions potentially during that welding process, or the removal of potential VOCs during which get accumulated, during the curing. So the environmental impact of what you're doing in your business is very important to us. And then finally, just to, I suppose, to give you that confidence, we have global, not only manufacturing, but also technical support. So we can help you with which is the right fastener, what IP rating you're looking to meet, what do you need to achieve that? How are you going to get samples? Like John said, we have the testing facility. So we're not just going to tell you this works. We're going to give you the data to give you that confidence that this is going to work in your applications. And then finally, we're going to help you with installation, be it yourselves or your production partner, to give you the right installation solution to get you the optimum, the most efficient installation solution. So thank you, John, for your technical overview. I'm going to open it up now for Q&A. Like Miriam said, we will answer as many questions as we can. We're aware that we're limited and your time's precious. If you don't get your answer today, if you've got something specific you want to talk about with your application, please feel free to reach out after this webinar. Like I said, just to reiterate, you will get a copy of this webinar. If you need more clarification, if you need more details, please feel free to contact us. So with that, I'm gonna kick off with some questions. Like I say, please feel free to add them in the chat. So I suppose the first question, John, what's the difference between, like, practically between IP67 and IP68 in real field conditions? Is there a real big difference when the numbers go up, when they change?
There can be, depending on the customer, because by the letter of the standard, IP67 is 1 meter depth for 30 minutes. So if you go deeper than 1 meter, or you go longer than 30 minutes and it leaks, well, then it has met it potentially has met IP67, but it is still leaked. So what I'd say to customers is that your application is probably unique. I think in real terms, what the standard we're seeing right now is IPX9K. That's really, especially in automotive, where you actually see the challenge. And curiously enough, what you see on that are things like not just the jet wash, which is obviously very hot and high powered jets, but also things like if you've got a hot component and you drive through a large puddle and you get a splash and stuff like that, sometimes that temperature delta can create a leak path also. And that's one of the things that we've tested against, obviously, using IPX9K, and that's why that is better. So you should pick the IP standard that's the minimum for your application. Because if something meets IP67, it'll meet that at a minimum. So that would be my advice, is when you're design, pick the IP standard that is your minimum requirement and set that as it. You can be confident in the PEM parts that we're going to meet IPX9K in any event. So if that's the one you want to set. But be careful, because even though we're able to meet it, not all your component suppliers might be able to meet that particular standard using their particular solution.
Thank you, John. The next one I'll probably, Miriam, myself can answer. Somebody's looking at, like, there's support material available, brochures, demo panels, PowerPoint. Like I said earlier, this presentation is available to you for sure. From a demo panel, what I would recommend, obviously, the only value of a demo panel here is if you want to test it. So we can install the product, but the value is in testing it really in your application. The product installed looks the same as an FH stud. So we haven't generated, as normally when we release a product, hundreds of demo panels, because it looks the same. It's the same process as clinching that we use, or very similar. But if you need application products in your specific panel to test, feel free to contact us. We can install the product for you. We can do the testing. We can share the panels back with you, and we can share the data. From a document side, for sure, we've got the presentation. And I think, Miriam, the standard brochure or guide will be available online for this as well.
There is a whole series of blog posts as well that we have, and a whole like thought leadership area that we'll include in the follow-up email from this webinar.
Yeah. Okay, thank you. Okay, so a question around material, John, and what materials this will work in. There's a specific one about like magnesium battery covers that one of the participants has asked about, John, as well.
Yeah.
So if you can give us an overview of what this will work and what potential limitations are, and maybe talk about, obviously, material thickness as well, if you could, in that.
Yeah. So it's got the same, and I've seen a question as well around performance. It's got the same performance as our FH stud from a mechanical perspective, and it will install into the same panels, and it'll have the same mechanical performance, i.e. torque out and push out. But they're functions of the panel it's installed into, so you'll have to look at the test results for that. As regards the panels that we have tested in, we've tested in steel, stainless steel, aluminium, and copper. And it works in all of those. I see no reason, and to be quite honest, I'd be very, very confident it would work in a magnesium panel. Now, I don't have the actual grade. You haven't given me the grade of the magnesium that's there, and whether it's a magnesium alloy panel or a cast mag alloy, which, you know, there are different properties, but in everything we've tested this in so far, it works, and it works very well. The performance lines that I showed on the graph, they're the performance in different materials. So whilst you do see variation, it exceeds the IPX9K by 2 decades. That's how good it is. So I'd be very, very confident that it would work in that. As regards panel thickness, as I say, if you look at we will be operating the same level I think it's down to 1.5 millimeter thickness, or maybe even lower. I'd have to look at the catalog, but all of this information is available in the catalog. But quite thin panel, it will work in. And to be quite honest, if you've got a unique material thickness combination, I would advise you to talk to us, because we will come up with a solution for this. We've put a lot of time, effort, and research into this from an NPD, a new product development perspective. We've had one of our engineers working on this for the last number of years, doing in-depth research into it. So we are very, very competent in achieving a solution, even in what you think may be a very difficult case to achieve ingress protection in.
Thank you, John. Another one about ratings, John. Question is, in industrial environments where there's fine metallic dust, what's the sort of minimum IP rating would we recommend for that?
Well, if we go back to, and Mark, if you scan back to the IP slides there, we did the smallest rating back to, I think, was slide 3, or yeah. this one here. So if you look at this here, no ingress of dust permitted is IP6 and protection against 6. So it's 66. IP66 is the minimum where you don't want any dust integrating. Beyond the first digit 6, there is no level. You're into liquids at that stage. And beyond IPX9K, you've gone into a gas tight situation, which is a different testing again. And that's a different role again, but that's something also that we can talk to somebody about. If they've got a gas tight requirement, we can talk to them separately about that. But to be quite honest, IP66 is the answer.
Thank you. Thank you. A couple of questions on installation, John. The first one is, like, how does our Hager system confirm that it's to the IP rating, or what unit? How do we get that confidence to our customer that installed means it's rated to an IP? Okay,
so Mark, if you go down to the one that has the graph on it of the slide that's on it, we have tested this at the envelope dimension, at the envelope performance. So using the force and distance setting on the Hager, that a properly installed part performs at this. So we have varied the parameters, and this is the performance you get. So when you use the Hager for the install, we give recommended settings on what a fully installed part looks like. Once you achieve that, you will achieve this performance. Just follow the recipe. It's pretty much easy as baking a cake in this case. Just follow the recipe, and what you'll get out the back end is very good.
Yeah, thank you. And the second one, John, is about obviously our customers who've already got Hagers. Is this special tooling they need to order for the Hager, or can they use the standard FH tooling?
The standard FH tooling works in this case. And this is what we've used in doing our test. Magic is in the part, not in the toolings. For thicker, much thicker panels, and it depends how thick you want to go with this, but for much thicker panels, we might recommend using raised ring tooling.
Yeah, I think the one thing for everybody here is, like, I would recommend, if you've got an application, we can do the testing for you. And like John said, by doing the helium leak testing, it reduces the time constraints. So each test, I think, John, you said, is 30 seconds. So we can give you that data in your application with the specifics. So, like, I would encourage that's the way we would like to work on these applications. Let us help you. Let us specify the right fastener, the right solution, and we'll give you the test data to give you that confidence that this graph that's showing here is actually your application and not a generic application that is for the whole product. Thank you. So I know we're running out of time, John. I'll try and get through a few more. Just on IP regulations, there's a question about, like, are we seeing the ratings becoming stricter? Like, are we seeing them? I think you said earlier, used to be IP66. We're finding they're going up. Is that something you're finding with the discussions you're having with the customers?
There is a slight trend. IP69K tends to be the maximum right now. And what I would say is that the advent of increased amounts of electronics being used in vehicles, because to be quite honest, in a static environment, you have less, rough handling, whereas a car is a very, difficult environment for any engineered solution. So therefore, IP69K came from that, and that's where that standard came from for use in automotive. That seems to be the limit right now. I think in most cases that will suffice for now. Once you go beyond IP69K, and our fasteners outperform that. If you look at the 1 by 10 to the minus 9 down at the bottom, that's gas tight, to be quite honest, because you're talking about helium and the machine isn't measuring anything below that. It's not capable of measuring it. So we're somewhere right now between IP69K and completely gas tight. That means that, we're at such a level as that I don't see anything further performance requirement beyond where we're at the moment. Let's say there's an IP, I don't know, 70K. That's a decade tighter, let's say 1 by 10 e to the minus 5. Well, the current solution that we have developed will meet that also. However, I don't see anything in the industry requiring that right now. But then again, who knows what's happening in labs all over the world that will require that water tightness solution. But what I would say is that by going with the PEM product, you're protecting yourself into the future as well by about 2 decades. So as you can see, the last move from 67 to 69K was 1 decade, and we're 2 decades beyond that again. So you should feel very confident that using our products, no matter what standard was to come out, we will meet that.
Thank you. That goes into probably our final question, John, due to time. In an IP69 box requirement, are there strict requirements like on hole tolerancing, min-max thicknesses for the material? I'll let you answer. I know what the answer is going to be, but I'll let you answer, John.
It's the same as in our for our standard FH part. It's in the catalog at the moment that the whole size, the whole tolerance, and anybody that's familiar with the PEM parts see that we give a very comprehensive description that's easily attainable for hole size and installation, etc. If you meet those, and we haven't made them any more stringent, then we will meet the performance requirement that you see here on the screen.
Yeah, thank you. And then I may just fit this final one and I can answer. Somebody's asking about the testing and obviously from a cost point of view, we see the testing as part of the service we give to our customers. So in a standard operation, there's no cost for that testing for our customers. If you want 5,000, 20,000 and you want us to do it consistently, obviously we need to discuss that. But on a standard test that we would perform, we can work with you, with the customers, with our distributors, and that's a service we think is part of what PEM's value is that we offer. So, like I say, please, if you have specific applications, speak to your local PEM distributor or direct representative, and we'll work with you on testing your application. And again, we can do this in whichever region you're based. So, I think Miriam, that's us out of time. Thank you, everybody, for your participation. I'll hand back over to Miriam if you just want to say a few words to close. Thank you.
Thanks, everybody, for your time. Really just reiterating what the team has said. Please do reach out to us directly, to any of us on the team, and we will triage your inquiries accordingly. There'll be a follow-up email with the link to the presentation and a link to the recording. So thanks again, and watch out for more webinars coming your way along these lines and other interesting fastener topics. Thanks, everyone.
Thank you, everybody.
Thank you.
Bye-bye.
Bye-bye.
Bye-bye.